All right, welcome back, everyone. I wanted to make you aware of just a real quick thing that we've added, which is a Python version of the first-person viewer simulator. Okay, so I pushed this up not too long ago, and I just want to walk you through how to interact with that. Okay, there is just the one branch on here, the main branch, and here we go. This is everything we need. The README here dictates exactly what you need. So the dependencies for this project, Python 3.7, NumPy, SciPy, and the matplotlib is one that you can utilize, but will not be used in default. And I'll explain that here in a minute. All you need to do is open up a terminal. This is designed to be run on a Linux system. If you're on Windows, go ahead and download a subsystem, a Windows subsystem for Linux, WSL. I use WSL2, and I just run this command from my terminal, pip install -e space dot. That space dot is going to get everything, and it's just going to make sure that you have all of these values ready to go. If you have another way to do this, that's perfectly fine, but those are our dependencies. And once you have them, all you need to do from your terminal is execute the command FPV sim, okay? And that's going to run the simulator. Now, one thing that I have inhibited in this simulator is actually plotting the scripts, okay? In the MATLAB version, we had a nice user interface that was systematically walking through different frames that the drone would see and moving the camera as the drone would move. I've shortcutted that functionality out of there while still enabling the drone to go through everything. Okay, and so we can actually dive into the FPV source, and we can see what we have. So we have our driver script, which is just the main function, right? Where it has our find gate commands, approach gate, fly through gate, okay? This is our main driver script. Now, I will let you know kind of beforehand, one thing that is expected of this, sorry, I'm getting ahead of myself. Let me just adjust real quick. One thing that is different about this is previously we had global variables that handled where the drone thought it was and where the drone's true location was. Those two things we have eliminated from the Python. It's not really good Python structure to do it that way. And so we did shortcut that out and actually just pass in a drone value for where the drone thinks it is and where it actually is. So true drone and estimated drone. Okay, so that's one noticeable check that's different. As we dive in to the rest, we can come back up here. And we can go into the modules folder. Now the modules folder is where we have organized all of the other commands that are necessary here. Now previously in MATLAB, we had each of these organized into a folder, and each file in that folder was a discrete command or function. What we've done here is we've actually reworked it so that each file is just a grouping or a module of all of those commands. So drone commands is exactly what you'd expect. We have our move drone command, we have our turn drone command, and we have our update drone command. Okay, so these are all there. I will caution you that this documentation is not quite accurate anymore. It was not updated. We had a little bit of scheduling issues, and this one did not make the block. So this is just copy paste from MATLAB. It will remind you what the purpose of these individual functions or methods are, but the specific sizes and what types of values they are not copied here. Instead, we did some typecasting. So in the actual inputs, you can see what the type is and also what the default values are. Okay, so I just want to let you know that and kind of be upfront with that. All right. A couple other things that I will show. So we go back to modules. We had a couple of other constants that were set in global variables. For this project, we have compiled all of those into a constants.py and given them the all caps nomenclature to indicate that these values do not change unless you're going to change them at the very beginning of the simulation before you start. Okay, so that's one noticeable change that we will be doing. And then everything else is organized roughly the same. Our drone commands you've already seen. Drone orientation has the orient to gate and orient to the global. Our global functions and our local functions are all here. Navigation functions that have the search for gate, fly through gate, approach gates. Our rotation matrices are here, and all the other utilities are down here. The one that is new is this initialization. Now, this initialization is exactly the functions that we used in the visualization, and we called them at the beginning of the driver script in MATLAB. So things like building the course and building a specific gate, all of those things we have brought over. A lot of the things that are missing from the, a lot of things that are missing from the visualization module in MATLAB are things that were used specifically to do the emulation of the computer vision, right? The things that were just showing what the first person viewer were. Those things we've removed. However, if you would like to add a plot frame command to this, that would be more than appropriate. And so we can go into our modules and look at our global functions. Right here. And these are all the true global functions. They still have access to some truth data, and get frame is right here. Now, from get frame, you will get the projected corners. Projected corners are your angles that your camera would be expecting to see. A noticeable difference between this and what your camera would see is that they've already been scaled. Okay, so these are the very central pixel of your camera is the 0, 0 point, whereas in your actual camera that we have set up for the drone, it's probably the top left corner that is the first pixel. So there is a translation that you should be aware of. The cameras that we chose have very little distortion, so we're not going to worry about the pixel to angular separation distortion. We're going to let that one slide, and it seems to work just fine doing that. The other thing, though, is instead of counting pixels, we are counting angles. But other than that, this is what your frame should see. So there's no reason why each time you run the get frame command, you can just add a little plot frame command at the bottom, where the only input would be the projected corners. And this is where you would use that matplotlib. Okay, so instead of getting a continuous feed of corner values, instead you're just going to get, each time you call get frame, which is a command that the drone will be operating on, it will do a single plot and show you all the corners that it can see. Okay, so that's how you would modify this. And because we're not doing the visualization, this is going to operate very quickly. Again, this is just a shell of the flight control software that we will be operating in the actual drone park. The only thing that we need to do to take this Python code and convert it to something that can fly on the drone is remove any dependency to truth data that it wouldn't be storing on board. So things like where the drone currently is located, that's going to be a physical parameter. It's not something that the drone will actually have access to, but it will have access to its motors to manipulate the true location. Okay, and so that's how we're going to interact this software with the Pixhawk. Any places where we have our drone commands. In the drone commands, we are going to, instead of accessing the truth information, drone.location, and then adding a little bit to that, we're actually just going to command from Mavros which is an interface in between the computer and the Pixhawk, we'll actually just tell the drone to move forward a certain distance. Okay. Same thing on the turn drone and the update drone. Update drone will just update the Pixhawk's assumed location, its estimated drone location. So those things we'll have to manipulate those scripts. Anything that has access to the true drone location is going to change. But other than that, this Python code is going to be very similar to what is actually flown on your drone. The last thing that I will say, you might have noticed that there's a new class in Python called the drone class. And the drone class is a very simple class. It's a drone object and it has a heading and a location, and that's it. Okay, so that's just a way for us to pass that information back and forth. So if you ever saw a drone.moveDrone command, it's just interacting with this class and giving a very specific feature to it. Okay, so that's it for here. I wanted to let you know that this is accessible for you guys to download and start interacting with. If you've made any modifications to the MATLAB code and you would like to port those modifications over to Python, this is a great place to start. Naturally, you're going to want to add in some plotting so that you can see step by step what's happening. You might also want to add in some pauses, right? Execute a command, pause, and then see where your drone has ended up. Did it do what it was supposed to? When you do the next step, does it correct those things? Does it move correctly to the next step? Whatever it is that you're looking for, that's what you want to play with this Python script for. All right, we will be modifying this Python script so that it interacts with our ROS core, which will be operating on the Jetson. But there's a whole separate video for that. All right, with that, thank you guys for listening, and please reach out if you have any other questions.